Well, then thanks a lot for joining, everyone. Today I'm going to present Pixi, the missing companion to cargo. And before I do that, I'll also spend a few words about myself. My name is Julian Hofer. I have a background in physics. And after finishing my master's studies, I did spend a significant amount of time living in the Netherlands and working on a water research company. So we did have a lot of modeling, a lot of scientific development. And we used mostly Julia because Rust at that point wasn't really suitable, but I always used Rust on the side. Because in general, I just love languages, human languages, programming languages. Please hit me up if you agree with that or if you're interested to talk about that. And I also love to talk about dependency management. And that's basically the point of my presentation. Before I do that, I want to spend a few words about the topic of the whole conference though. We had now a couple of really impressive presentations. So I applaud your work, Martin, on DiffSolve. There are a lot of reasons why we use Rust, right? Like the main reasons why people use Rust at all, they fully apply to why we as scientific developers use Rust. We like speed, which Rust provides. We like thread safety, which is basically a different way of saying we like speed, because we like using all the cores of our machines, so we want them to be fast. I would argue that even memory safety is mostly about speed for us, because we want to use lifetimes, we want to have references everywhere without a program crashing, so it's still speed. But if Rust is the most suitable language, if it's the way to make the fastest programs possible, then I always wondered why is no one using Rust? People are using Rust in many domains more and more, but in scientific programming, I feel like it's not really taking off, even though we have these amazing conferences. And I think there are a couple of really profound reasons why people are not using Rust. If you look at DiffSolve, it's really complicated traits. You already mentioned, Martin, it's not as bad as C++. I would also argue it's significantly worse if I use Python. It's also significantly worse if I use Julia. And Julia has a similar complexity, has a similar speed as Rust. I can do nothing about it. I think that will always be an inherent problem with Rust. But there are problems that we could fix, like the difficulty-dependent libraries not written in Rust is not specific to the language, but specific to cargo. So it doesn't have to be always tied to Rust. Also, lack of high-quality libraries, that doesn't have to be that way always. We could change that. That could change in the future. And those 2 points is also what I want to address here. Mainly, the cargo is just not enough. If you're fine with relying on Rust-only libraries, if the DiffSolve is fine for you, then perfect. Cargo, you can use that, and you don't need anything else. Chances are it's not enough, because there are existing libraries. Some of them might not exist in pure Rust at all. Some of them just don't provide all functionality or don't provide the same quality. For once, but there are also more to it. Cargo doesn't have a task runner, which is, if you do scientific development, is quite important. You have a pipeline, you have a bit of data, you process it, you do something else, you compile a program, run it on your data, and you have output data. So you always need an external tool. But more problematic, I would say, is that you cannot really easily depend on scientific libraries. Unless you rewrite it in Rust, you have a specific program that someone else already rewrote in Rust, or you do it yourself. Simple things you could also compile yourself. If you just assume that you have a C compiler in your system and it's only a simple small C library, you probably get away with just compiling in build-as, which does it shortly before your Rust compilation. Question is though, where does the compiler come from? If you don't have that, how do your colleagues then deal with that? Also, if that library you build has a dependency by itself, all of that will definitely crash and burn. One thing that could work is that it would detect the library in your system, the traditional way. If you're in Linux, for example, you could install Cheers with your package manager, and then use the Rust wrap around that, and that will detect the shared library on your system. And if all of your colleagues use the same Linux distribution, all of your collaborators use the same Linux distribution, that kind of works if you have a common Docker container. But if some of them using Mac, if one of them is using Windows, all of that will again not work. You would have to somehow convince them or somehow help them to get the library in a findable path on the system. The more libraries you add like that, the more difficult it will become. And all of the advantages of Rust, that dependency management is easy, will completely go out of the window. directly in dependency hell. And of course, I'm biased, but I think the right way, or the best way for Rust developers, for scientific Rust developers, is to just use an external tool. And a couple of them available. There's Nix, there's Docker, there's Bazel. I will present the one that I'm working on, which is called Pixi. And the reason why I think it's the most suitable one is because it's already fully focused on the scientific, on exactly that problem just for the Python ecosystem. Because it's based on the conda package ecosystem, which was designed when Python, I think 15 years ago, had exactly the problem that Rust had right now. Like Python couldn't deal with binary packages back then. So conda was created to be a cross-platform, cross-language package manager, which provides you all of the scientific Fortran, C, C++ libraries, while still allowing you to use Python. But exactly the same would work for us as well. It's very similar to Cargo in the way it works. It's written in Rust, it's fast, open source, it has log files. It manages your workflow, so it has pipelines and task graphs and everything like that. And it can also manage multiple environments. Without further ado, I want to give you a short demo. So let's imagine this is like a very simple Rust program. You use the geos library, which is a popular library if you ever did, basically if you did any kind of geometric calculation, if you're in GIS field, or basically any kind of geometric calculation, you probably use geos. You can use that in Rust, but what you install there, if you install it with Cargo, you just install the Rust wrapper. What this wrapper does, if you then compile it, it will search in the system if the actual library is somewhere findable. The way you use it is you just basically a normal Rust program. We create a geometry. In that case, it's just a square of 5 times 5. And then we ask geos to calculate the error first. Well, a square of 5 times 5 should be 25. And we want to use Pixi to help us with that, because if I now use Cargo run, for once it will not work because I don't have Rust installed in the system. But even then, it would complain because geos is not installed. So Pixi is like the missing companion here. It can deal with source packages, but like the main use case, the main thing why it's created is to deal with binary packages, the thing that Cargo basically cannot deal with at all. So you also have a toml, you tell it where should the binary packages come from, which platforms do you want to support, and then it has a log file which is empty at the moment. So I can add Rust to it. Then I have Rust in my dependencies as well as in my log file. So basically everything that makes up Rust is now stored in my log file. And I can now run Pixi run Cargo run. Rust is now available, but it still will not work because it complains about error while loading shell libraries libgeos. So that's exactly the problem that you would face with if you would use Cargo without Pixi. You would now use your Linux package manager or your Mac package manager or whatever you would use in Windows to somehow get libgeos installed. Maybe you have to compile it yourself. What you can do with Pixi though, you can now install package config, which is a tool to find libraries in the system, as well as the geos library itself. And that one is now added to your Pixi environment, which is a local folder, which basically contains all the libraries, including libgeos here. That, by the way, also works on Windows and macOS. If I now run Pixi run Cargo run again, now it works. It finds the geos library on your system, it finds the geos library in your environment, and it can now do the calculation here. Also mentioned the workflow manager, so I can add a task, which I call start, Cargo run, and now it's also self-documenting. Whatever task you defined here, it's clear that these are the ones that you want to mention. These are like the typical workflows. There are also task dependencies and all kind of fancy workflows. If you're interested, you can check out our documentation. But now I can run Pixi run start, and we'll run it. As a conclusion, I'm really optimistic about scientific Rust. I think the complexity is annoying, and it will always be like people will always compare it to simple languages like Julia. But there's also things that something like Julia, for example, doesn't have. It doesn't have the thread safety. It doesn't have it's not just as in performance, like the last bit of performance is still restricted to language like Rust. It's significantly less problematic than C++. So I for sure think there's a need for it. The reason why I think that Pixi is more suitable, not just because I work on it, but the conda ecosystem is just specifically designed for the use case. Like if you go to Nix, if you go to a different ecosystem, chances are you will have a less persuasive ecosystem for scientific libraries. And that's not at all the case for conda. Everything scientific is already there because they had to do it for Python beforehand. And Pix is just a really nice iteration on conda, which is declarative, which is a log file, which is really fast. It's just a nice tool and fits in well to Cargo, in my opinion. And that was my presentation. Please check out our website, my LinkedIn, or our Discord, and shoot questions if you have them.
Thank you very much for your talk. I have one question in the Q&A. It says,
Yes.
Can I use Pixi to publish crates on crates.io such that other users can use them within the regular Cargo system? If not, how large is the barrier for people who want to use my library?
Yeah, that's actually an excellent question, Jonas. You can absolutely still publish everything in Crato, but people who are using a library will still face the same problem, right? Like you need geos in that example. So the consumers of your crate will just have to somehow figure out how to get geos on the system. But apart from that, there's nothing stopping you. Like it's just an abstraction on top of it. It's still using Cargo normally as usual.
Okay. Well then, thanks again. Oh, there's another one that says could be read beyond Science FFmpg, which is very hard to install for Rust.
Definitely, it's also something that we want to push in general to make conda more popular outside of science as well. FFmpg is something that's definitely published on CondaForge. I use it at least once a week. It's also really useful for other development tools like GH or RipCrap. Although everything that isn't specific to isn't only useful for a specific language ecosystem is often published on CondaForge, and it's just nice to install it that way.